We are going to continue with chapter 3 today. Today's all about functions. So get your notes out. We are starting on that second page. Third page. There you go. All right, we're going to start with some vocab. So the first vocabulary term is relation. A relation is a set of ordered pairs. We call the domain the set of all the x coordinates and the range the set of all the y coordinates. All right, so here's example 1. It says, given the relation, state the domain and the range. So remember, the domain are all the x's. So -2, 0, 1, and 3. We always want to put those in order from smallest to biggest. They just happen to be in that order. But you can see on the range, they're not in that order. So the ranges are the y's. So like 5, 2, -3, 5. But you want to list them in order from smallest to biggest. So -3 is the smallest. Then what? 2, 5. Now, if something repeats, you don't have to list it twice. Okay, so just 1, 5 is fine. Any questions on domain and range? They are a set, so we're writing it in set notation. So put the braces around it, the little like squiggly parentheses things.
It already has it.
Yeah. I'm just saying, when you write your answer on your homework, I expect to see those. Questions so far? All right. There are various ways to picture a relation. So we are going to show it in a table first. So if we're doing a table, that's like what we did yesterday. So if I wanted to show this one in a table, it would be -2, 5, 0, 2, 1, -3, and 3, 5. So if I say make a table, like on your homework last night, you're expected to make a table for your graphs. That's what a table looks like. You can also see it in mapping format. That's where we start with the x's. And then the y's, usually the y's are in order as well. So we'll do -3, 2, 5. And then we show using arrows which two go together. So like the -2 goes to the 5. The 0 goes to the 2. The 1 goes to the -3. And then the 3 also goes to the 5. Or like we practiced yesterday, you can just graph these. So -2, 5, 0, 2, 1, -3, and 3, 5. Okay? And if you're graphing a relation, just a set of ordered pairs, you don't need to connect them. This isn't like a connect the dots sort of an example like we were doing yesterday where we graphed the line. You don't need to connect these. All right, any questions? So a function is a relation in which each element of the domain is paired with exactly one element of the range. So basically, none of the x values can be the same. So if you have an x value that repeats and gives you a different y each time, it is not a function. To be a function, each x gives you one y, okay? Like you can't have 2 as an x, like you can't have the 2 ordered pairs like 2, 5, and 2, 7. See how the x is repeating? That would make it not a function. So all the x's have to be different if it's going to be a function. Any questions? We'll look at some examples too. That's just kind of the easy way to describe it. All right, so we are going to tell whether or not the relation is a function. So remember, in order to be a function, the x's cannot repeat. So is part A a function? No. Do you see how 0 gives you 2 and gives you -3? That means it's not a function. That's the problem right there. Now, in part B, do you see how 2 of the x's give you the same y? That's fine, as long as the y's aren't the ones, or sorry, as long as the x's aren't the ones that are repeating. So that one's fine. Now, if you had 2 arrows coming out of the same x, like if 5 gave you 0 and -2, that would be a no. Okay, as long as your x's aren't repeating. Now, on part C, remember x's are like our left and right. So over here, if I go left, this many, I only have one y, right? Left this many gives me one y. Left 1 gives me this y. Not moving at all. Okay? So do you think that one's a function? Yeah, none of the x's have more than one output or more than one y, so that one is a function. Any questions on function versus not function? All right, what we just did on part C was an example of the vertical line test. So a relation is a function if and only if no vertical line can be drawn that intersects the graph of the relation in more than one point. People also call this the pencil test because you can take your pencil and slide it along the graph, and if it touches your pencil in more than one spot, it is not a function. Okay? So you have these in your notes. So if you take your pencil, I'll show you with my pen. If you slide it along part A, do you see how the graph is only going through my pencil once? Mm-hmm. So this passes the vertical line test. So you would put, yes, it is a function. Now part B, if you put your pencil right there, how many times is that graph touching your pencil? Twice. Now it's touching it twice. So this does not pass the vertical line test. Try it with part C. Does part C pass the vertical line test? No, it does not. And D? Yes, it does. Do you have a question? Are all lines functions? No. What type of line would not be a function? Circle. That's not a line, that's a circle. What kind of straight line? Yeah, if you have a vertical line, it would not be a function because the whole line would be on your vertical line during the vertical line test. So vertical lines are not functions. But all other lines are functions. Those aren't lines. Those are inequalities. Those aren't lines. Lines don't have any bends. It's just an infinite straight path. All right. Function notation. This is where it gets really fun. So this says normally we see functions written like this. This is what we looked at yesterday, right? We get the y by itself. We plug in x's. We get a line, right? This is function notation. In function notation, we take the y out and we put that in. That is f of x is how you would say that out loud, okay? It does not mean f times x. It basically means you're putting an x value into the function, okay? So it's really just a complicated way to write the y. The cool thing about function notation is whatever you're plugging in, let's say we're plugging in 0 here. You would put f of 0 equals, and then you replace all the x's with the 0. So it gives you a little bit more information than just using a y. But don't overcomplicate it. We're not multiplying by f. We're not doing anything crazy like that. It just says what the function is written in terms of. So this means a function of x. Or if we put a 0 in, it would be the function at 0, okay? All right, here's example 4. If f of x equals 2 minus 3x, find these values. So we're saying we want the function at 0, or f of 0. So we're going to take all the x's out. We're going to put a 0 in. Do that now. Now, on the left side, this is already done. You're not doing any math here. You're not dividing by 0 or dividing by f or anything crazy. This is done. It's just like saying, this function is what I started with, but I took all the x's out and I made them zeros. The right side is where you do the math, okay? So we would do 3 times 0, which is 0. And what's 2 minus 0? 2. So f of 0 is 2. Or this function evaluated at 0 equals 2. Questions. That's super, super important. And that will not go away. You will see this the rest of this year, your whole junior year in Algebra 2. This is a concept that you need to know. All right, we'll practice again with a -2. So now I want f of -2. So I'm taking all the x's out and I'm making them -2's. This is done. There's nothing else to do here. It's just a fancy way of saying, hey, I had a function and I made all the x's -2. Here is where the math is being done. So we have -3 or -3 times -2. What would that turn into? A +6. Good. So this function evaluated at -2 equals 8. Questions? All right. Now I'm taking all the x's out, and what am I putting in? 2/3. So this function evaluated at 2/3, or f of 2/3, equals 2 minus 3 times 2/3. What happens to the 3's? Good. So I have 2 minus 2, which is 0. So this function evaluated at 2/3 equals 0. All right. Is everyone caught up? Because might be where it gets a little tricky. You can put more than just a number into a function. Here I'm going to put an expression in. So I'm going to find this function evaluated at m plus 2. Same idea though. Take all the x's out. Here's an x, take it out, put an m plus 2. Here's an x, take it out, put an m plus 2. I took each x out. I plugged in m plus 2. Do I do any math on the left side? Nope, that's just notation. What you can do here is distribute the -3 or the -3. So this function evaluated at m plus 2, or f of m plus 2, equals 2 and then minus 3m minus 6. The only like terms here are the 2 and the minus 6. So I have -3m minus 4. If you did -4 minus 3m, that would be fine as well. Yeah, those aren't like terms, so we can't do anything with it. We don't know what m is, so we're done. Now, I will admit, this is pretty complicated stuff. And this is where it gets to be even more important that you're doing your homework each night. Because if you're not practicing this notation and getting used to writing it this way, there's no way you're going to do well on your quizzes and tests. It's just not going to happen, okay? So you have to be doing the homework every night. You have to be using your class time, okay? This is getting to be challenging, and it's only getting harder every single day. Do you guys have any questions? Okay. Here's the next one. So now our function is -x squared minus 2x plus 5. I want to start by finding f of 0. So I'm going to take every x out. I'm going to put a 0 in. So f of 0 equals negative 0 squared minus 2 times 0 plus 5. What would that give me? 5, right? It's 0 minus 0 plus 5. So f of 0 equals 5. All right, now I'm going to find f of 2. So I'm going to take every x out, and I'm going to put a 2 in. So take this guy out, put a 2 in. Take this guy out, put a 2 in. So f of 2 equals negative 2 squared. Am I squaring the negative? No, you're squaring the 2, then you're making it negative. Okay? And then minus 2 times the 2 plus 5. So what do I get in this first term? It's going to be a negative 4. You square the 2 first, then you make it negative. So it's going to be a negative 4 minus 4 plus 5. If you're unsure of that, type it into the calculator exactly as you see it. Don't put the f of 2 part. Just put the after the equal sign. Remember, this is just notation. We're not doing any calculation over here. Here is where it's all happening. And the calculator knows the difference between a negative in the parentheses and a negative outside. All right, what is negative 4 minus 4 plus 5? Negative 3. Good. All right, this next one's going to be tricky because I am finding f of negative 3. So I have f of negative 3 equals the original negative, then the parentheses, I'm making x negative 3. Now, do these negatives, can I just make them a big positive? No, I absolutely cannot. This one is being squared, this one is not. You cannot deal with them yet. You have to do exponents first. Now, back here, these two are going to become a plus. That's not a problem. But you have to do exponents up front. So what is negative 3 times negative 3? Positive 9. Then you deal with this negative. So negative 9. Yep. Take a minute and let that part soak in. That was a lot. Once again, it's an order of operations like technicality there. You have to take care of the exponents before you can multiply the negatives, okay? Or if you think of this part as being squared, it means it happens twice. So it's a negative times a negative 3 times a negative 3. So 3 negatives is how you end up with a negative at the end. Questions? What's going on over there? In the middle. Nothing? Do you want me to write it out?
Yeah.
Okay, so I'm just going to focus in on this piece right here, right? Okay. What I have is a negative, and then negative 3 times negative 3, because the negative 3 is in parentheses being squared. So what's a negative 3 times a negative 3?
Okay, never mind. I get it now.
Yep, okay. So you only have the one negative in the end, okay? All right, negative 9 plus 6 is negative 3 plus 5, positive 2. That was a lot. But again, the calculator knows how to do that. If you typed a negative, then the parentheses, negative 3, close the parentheses, square it, it'll do the whole thing for you. Questions? We are not. I am serious. Yes. So this is saying we want the function of the f function evaluated at 2. See how we have a different function now? So we have two functions. We have an f function, f of x. We also have a g function, g of x. So it's two separate functions. If I'm plugging a value into the f function, I'm using this. If I'm plugging a value into the g function, I'm using this guy back here. Okay? So I want f of 2 first. So I'm going to plug a 2 in here. Then I want to add to that g of 2. So now I want the g function evaluated at 2. So let's do them separately. F of 2. So put a 2 in right here. Two squared is 4. 4 minus 6 is what? And then I take the absolute value, which is 2. So f of 2 is 2. That's like the first third of the problem. Are you ready for the second third of the problem? It's at the absolute value of -2, which is 2. See these bars? Yep, so you make it positive. All right, now I want the g function evaluated at 2. So I'm going to plug a 2 in here and a 2 in here. What does that give me? So 6 minus 1, which is 5. All right, I'm going to stop here, let you catch up because that's a lot. Like I said, this goes quick. Now what? Add them together. I want to add the f of 2 and the g of 2. So 7 is the answer. It's getting even more complicated because I want 5 times f of 3, which means I want to plug 3 in here. I want to evaluate it. Then I want to multiply it by 5. I want to divide that by the g function evaluated at 1 and then multiplied by a 2. So I'm just going to go piece by piece. F of 3. Go to like your innermost function, sort of work your way out. So f of 3. So go to the f function, plug a 3 in, figure out what that value is. Okay? So I want 3 squared. What's 3 squared? And what's 9 minus 6?
3.
And what's the absolute value of 3? 3. All right, I'm going to slow down, give you a second. Now let's do the g. So g of 1. So now I'm plugging 1 in to the g function. So g of 1 equals 3 times 1 minus 1. What is 3 times 1?
3.
And 3 minus 1 is 2. All right. Now I'm going to plug those values in. 3 right here for f of 3. And 2 right here for g of 1. Okay? So you can see 5 times f of 3. Well, I know that f of 3 is 3. So 5 times 3. And 2 times g of 1. Well, g of 1 is 2. So 2 times 2 is down here. Now you can actually do them. What do I have in the numerator? 15. Denominator, 4. That's it. Yep. There's no common factors of 15 and 4, so you're good. So part C, now I want -2 times g of 5. So let's do g of 5 first. So I'm going to go back to the g function and I'm going to plug in a 5 everywhere I see an x. So g of 5 equals 3 times 5 minus 1. What's 3 times 5?
15.
And what's 15 minus 1? 14. That's not it because I got to multiply the g of 5 by -2. So negative 2 times g of 5, but I already found out that g of 5 is 14. So you get a negative 28. Good.
Oh.
Is that what you said? Oh, okay. Sorry. I just heard what I wanted to hear, I guess.
So we still gotta write the negative 2?
Yeah. Like the one in front? Yeah.
Because wouldn't they cross cancel?
No, remember, this side is all just notation. We're not doing any math on the left side.
Okay.
You don't go through and like divide both sides by 2. It doesn't work like that. This is just basically telling you, hey, this is the math I'm doing. Here is me doing it. Okay? All right, part D, we've got to plug in negative 3 to the F, 2/3 to the G, and then add those results together. So let's start with F of negative 3. So I need to do negative 3 in parentheses squared first. What is that?
9.
And what's 9 minus 6? 3. And what's the absolute value of 3? 3. So F of negative 3 equals 3. Now we do G of 2/3. Good. So G of 2/3 equals, looking at the G function again, 3 times 2/3 minus 1. What happens to the 3's? Good. So we have 2 minus 1, which is 1. And what am I doing with these results? Adding them. So I want to add F of negative 3 with G of 2/3. Well, I know that F of negative 3 is 3, and G of 2/3 is 1, and 3 plus 1 is 4. That's your answer. So we have a function graphed already on the board. Do you all see that function? Okay. Now, I want the function where is this the x or the y? The x. I want this function where the x is 6. So how could I find on this graph where x is 6? Go right 6. 1, 2, 3, 4, 5, 6. What is the y value? 2. So this function where x is 6 has what value? 2. So it's just saying use this function. This is my function. When x is 6, where's the function at? It's up here at 2. Okay? What's the value of this function when x is negative 7?
0.
What is the value of this function when your x is negative 2? Yeah, it's probably a lot easier to follow along on your actual piece of paper, right? You can use your pencil and draw on it. Okay, so again, where is the function when x is 6? It's up here at 2. Where is the function when x is negative 7? It's way over here. Where is the function when x is negative 2? It's right here. It's up at 2. Okay? So this tells you the x value. This is the corresponding y value, basically. Questions? All right. Now, here's another way to look at this. Given this table, find f of 3. So where the x value is 3, what's the function? -6. Perfect.
Today we
Questions? All right, today we learned a lot. Let's.
Today we learned about sustainable use as adults.
Today we learned
functions.
all about functions. This was a lot about functions. All right, here comes your homework again. It is so important that you're doing this. We are learning a whole bunch of little ideas that are going to get deeper and deeper and deeper each day. You have to practice. You have to keep up.